Lesson 8 involves covalent compounds, and we're going to focus first on their bonds, covalent bonds. We will also be reviewing or introducing the idea of ionic bonds as well, but we'll cover that in depth in another lesson. Before we get to looking at the bonds, we need to look at how we represent the electrons and how we draw the bonds. Okay, so we're backing up a little bit to do a little review so we can start drawing these electrons. The periodic table that I give you for the test has this zigzag stair step already written on there for you. So where are the nonmetals? They're up here, aren't they? And of course, hydrogen is a nonmetal as well. The metals are all of this. Most elements are metals, even though most compounds are made from nonmetals. So this lesson in covalent bonds is really, most of the molecules in the world have covalent bonds. We also need to look at the periodic table and say how many valence electrons an atom has. Valence electrons are electrons in the highest energy level. Highest principal energy level. Those are the electrons that are closest to the outside of the atom, and they're involved in bonding. So we can look at the periodic table and say that these have one valence electron. They have one valence electron in an s orbital. These have two valence electrons. Two electrons in an s orbital. And then we're over here to the p block. These have two electrons in an s and one electron in a p. So these have three, and then it just counts like this. When we get over here to the noble gases, notice they have 8, except for helium, which we've moved over here. Helium has 2. The rest of the noble gases have 8. Now we're ready to start drawing Lewis dot structures that show just the valence electrons. So on that periodic table, carbon is in the column for 4. We're going to put 1 on each side. That's sometimes convenient, but it doesn't really matter all that much. We need to, usually I pair them up if I have to. That sounds familiar, doesn't it? It doesn't matter which side I put the single ones on. In other words, I could do this. What is important, though, is that you keep the electrons arranged on a box. So, for example, if this is X, I'm going to draw 8 electrons for it. These are the 8 positions that it can have, that the electrons can have. Notice that they fall on this square or box. In other words, the ones on the side are up and down. The ones on the top and bottom are side to side. So over here we did this. And this just makes the drawing come together better when you start putting atoms bonded to other atoms. Let's define bonds. Bonds are forces that hold atoms together. The reason that we study them is that the bonding determines a lot about a compound, a lot of properties of a compound. Reactivity, solubility, like does it dissolve in water or in something like gasoline. Physical state, I mean solid, liquid, or gas. The shapes of the molecules, which is certainly very important in the states sometimes, and also in biochemistry, the shapes of the molecules is a huge issue. Why do atoms form bonds in the first place? Well, you kind of know their goal is to increase stability. Lower energy states are more stable. So we mean a lower energy state. And let me just use an analogy to talk about why lower energy. Let's put a ball at the top of the hill. And we'll put another ball down here at the bottom of the hill. Which one is more stable? Because it's down here on the ground, it's more stable. This one is in a precarious position. It's a higher energy position, and so it's less stable. So that's how you can remember that. And literally, this is how the energy works. So this is an energy diagram. And what makes them stable? If they have an electron configuration that's like a noble gas. That means 8 valence electrons for most of them, but the really small ones are happy with 2 electrons like helium. So that's where we get the word, the octet rule.